Okay, so let's have a look at another topic, which is the electromagnetic spectrum. So as you can see in this picture, we have this picture shows the electromagnetic spectrum. What is it? It contains a broad range of wavelengths. What is a wavelength? We'll see that. So wavelength is, let's have a look at this sine wave from this point to this point, from this top to this top. It means like this. At this waveform, we call it as a wavelength indicated by lambda, or from this bottom point to this bottom point, we will call it as a lambda. That is one wavelength. Okay, so there is a electromagnetic wave and it has a length, it has a size, it has a scale that is called one wavelength. And this electromagnetic spectrum, this whole picture contains various types of waveforms. So what those waveforms are, they are called as radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays, and so on. But these, as indicated here, they are the main sources of the waveforms. So first, let's have a look at here. So what we see that this is showing a waveform which is increasing in the frequency. As you can see from left to right, right up to here, that is shows increase in the frequency. So it's very high frequency at the right end, and at the left end we have a small frequencies. So accordingly, the wavelength can be classified. So you see here the frequency, the waveform which has a small frequency, as we can see here, right from here, such as radio and microwave, it has a small wavelength. For example, 10 to the power 3, which is meter, indicated in meter. So it's like 1,000 meter for radio wave, like let's say 10 to power minus 2. So it's like 100 centimeter for the microwave, 10 to the power minus 5, or 0.1 or 100 microfarad, something like that for the infrared, and so on. So as the frequency is increasing, the wavelength is decreasing, right from 10 to the power 3 to 10 to the power minus 2, minus 5, and you can say up to 10 to the power minus 12. So remember, as the frequency of a wave goes up, the wavelength of that wave, the wavelength of that wave goes down. Okay, so frequency is up and the wavelength goes down, right? As you can see that. And now, what is the wavelength? What is the scale of the wavelength? So as I said, that 10 to the power 3 meter is like 1,000 meters. So it's, let's say it's a tall building, like 11th floor buildings or something like that. So that big is that waveform. For a microwave, it's the height of a human, let's say 6 feet or something like that, or 100 centimeter as indicated here. Then you have this in between microwave and infrared, you have a waveform that has a wavelength of the scale of the butterflies, this size, you can say that. And then you can say that the wavelength goes very, very small, up to the size of atoms and atomic nucleus. So now you see the frequencies. The radio wave has a scale of wavelength up to 1,000 meter. The frequency is very low. It's about, let's say, 100 kilohertz, as you can see here, because the wavelength is big as the size of building. Next, microwave is right here, 10 to the power 8. So it's basically very, very high, from 10 to the power 4 to 10 to the power 8. So you see the wavelength goes down, the frequency goes up, or vice versa. Then for the infrared, you have 10 to the power 12 light gigahertz, and you have this visible light like 10 to the power minus 15. So you see now this is indicated by black color, and then this is also indicated by black color. It means those signals or waveforms or electromagnetic radiations we can't see by eyes, but in the middle you have a certain range of frequencies. Those are called as visible lights or visible wavelengths, which can be seen by us. The final is the temperature. So as you can see that this shows the temperature of objects at which the radiation of the most intense wavelengths are emitted, you know. So you can, it starts from 1K for the microwave and radar, and the temperature increases at which these emissions are radiated into the space. Okay, so as we've seen that the electromagnetic spectrum, it contains broad range of wavelengths. The spectrum includes various types of waves, as we've seen that radio, microwave, infrared, etc. And each type of the wave has specific wavelength and specific frequency. So for example, if I ask you, tell me the wavelength for the radar wave. So the wavelength indicated by lambda is about 10 to the power 3, and the frequency of the radar wave is about 10 to the power 4. This is in meter and this is in hertz. Remember, meter is the unit of wavelength and hertz is the unit of frequency. So you see now 10 to the power 3 here, 10 to the power 4 here. If I ask you to tell me the wavelength for the gamma rays, so lambda is equal to 10 to the power minus 12 right over here. And the frequency of the gamma is very, very high because the wavelength is so small. Is minus 12 is such as a picometer, right? So we'll say that the frequency is 10 to the power 20 hertz. So this is how you actually can indicate what is the frequency of a specific waveform by looking at the electromagnetic spectrum.